All right, chapters 15 and 16, we are cruising right along with our physical science unit. Now, remember, we've talked about chapter 11, velocity, acceleration, distance, displacement. Chapter 12, force is equal to mass times acceleration, Newton's law. Chapter 13, pressure, density. All right, chapter 14, work, joules. This is we're kind of halfway home. We're going to talk about energy. Now, what is energy? All right, let's talk about what is energy. Energy is the ability to do work. All right, we transfer energy by moving force and object in a distance. Now, remember, work is very similar to energy. In fact, if you think about work, the equation for work was force times distance, right? What was our unit for work? Joules. Our unit for energy is also going to be joules. So it's our ability to do work. Work is the transfer of energy. As I just talked about, work and energy are both going to be measured in joules. So what types of energy exist? Think about this. In your world, what types of energy exist? Just real quickly, kind of think about it real quick. I gotta shuffle the PowerPoint here real quick. What types of energy exist in your world? All right. Let's talk about them. Forms of energy. Chemical energy. We spent the entire first year talking about energy, chemical energy. That's energy stored in chemical bonds. That's how a battery works, guys. Chemical energy. Electrical energy. The use through electrical charges. All right. The forms of energy in a battery are both chemical and electrical. You have electromagnetic energy, and we're going to talk about this in chapter 16 or 17 and 18 when we talk about light. That's how light travels through space. Nuclear energy. You might have heard about nuclear energy and nuclear bombs. All right, that's kind of how nuclear energy works. That's the energy stored in the nucleus of an atom. Now, what else can we talk about? There's what other types of energy are there? Well, there's mechanical energy. Holy cow, look at that definition, mechanical energy. Oh, that mechanical energy is the amount of effort required to go into an object to make it move. So, sorry, I'm moving all over the place on this slide. We have mechanical energy. Holy cow, look at that definition for mechanical energy. It's really the sum of our potential and kinetic energy. And what we're going to talk about here in a second is what is kinetic energy and what is potential energy. All right. We also have thermal energy, and thermal energy which is probably what you call heat. But that's the kinetic and potential energy of all the particles in the universe. And we're going to talk about what creates heat. Particles moving is what creates heat. So we have chemical energy, electrical energy, electromagnetic energy, and nuclear energy, mechanical energy, thermal energy, all these types of energy. But let's talk about the two most important forms of energy. And the first is potential. And potential energy is the energy that is stored as a result of your position or shape. What the heck do we mean by that? Well, let's talk about this. You guys all go sledding in the winter, or you've all maybe hopefully been on a roller coaster. You're climbing up to the top of that roller coaster, and you're at the very, very top of that roller coaster. Are you really moving at the top of that roller coaster? Or when you're sledding, are you really moving when you're at the top of the hill? No. But what's it take? All you need to do is go over the edge and you're moving because you have tons of potential energy because you're at the top of the hill. Gravity is going to take you down. So, anytime you raise an object, the higher you are, the more potential energy you have. So potential energy, PE, and we're going to abbreviate potential energy, is equal to mass times gravity times height. So if we write this out, PE equals mass, mgh. Mass times gravity times height. Mass is in kilograms. Gravity is 9.8. Remember, that's a constant because we're on Earth. And height has to be in meters. The unit for all types of energy is joules. So PE is equal to mgh, mass times gravity times height. The higher you are, the more potential energy you have. Kinetic energy. Let's talk about kinetic energy then. Potential energy was stored energy. Does anybody know what the word kinetic means? Kinetic is energy in motion. So kinetic means moving, guys. The word kinetic means moving. So if you have kinetic energy, you are moving. So just think of that. Kinetic energy, you are moving. All right. It's based on its mass and its speed. So what's our equation for kinetic energy? Kinetic energy is equal to 1/2 times mass times velocity squared. That's the key one here. Ke is equal to 1/2 times mass times velocity squared. M is mass. V is velocity. Now, there are no circles for these problems, guys. You're going to have to use algebra, and you're going to have to divide accordingly. So I can't come up with any circles to kind of help you out. So what we're going to have to work on is plugging numbers in and doing algebra, which you guys are all capable of doing. So we have potential energy is equal to mgh. We have kinetic energy is equal to 1/2 mv squared. So let's go ahead and let's walk through an example here. A 0.1 kilogram bird is flying at a constant speed of 8 meters per second. What is the bird's kinetic energy? Well, remember, we want to write down everything we have. So we have, all right, 0.1 kilogram bird. What is that? That's mass. Right, is flying at a constant speed of 8.0 meters per second. What is 8.0 meters per second? Velocity. Then we're solving for what is the kinetic energy. So we are solving for Ke. Ke equals question mark. Well, we know that Ke is equal to 1/2 mv squared. So let's plug in our numbers. It's equal to 1/2 times our mass, 0.10, times our velocity squared. So we're going to plug in 0.5, which is 1/2, times 0.1, times 8.0 squared is 64. 1, and then you're going to multiply everything together. 0.5 times 0.1 times 64 equals our kinetic energy of the bird is 3.2. What is our unit? As always, for anything for energy, our unit is always going to be joules. So there's an example. That's an example using kinetic energy. We very well could do an example using potential energy as well. Remember, potential energy is equal to, all right, potential energy is equal to mgh. So we are going to stop there for section 15.1. Remember, there are tons of types of energies. We have mechanical, electrical, chemical, but the two that we are going to focus on is potential, and potential is equal to mgh, and kinetic, which is equal to 1/2 mass times velocity squared. All energies units are in joules because it's just like work. So this concludes section 15.1. This is Ms. Clinton, and I'm signing off.